Morning, Andrea. Good morning, everyone.
Good morning, Massimo.
And thank you. Thank you for your participation in this GEM International webinar dedicated today to safety relay and their application. Join me today, my colleague Andrea Spolar, who will help me to lead this webinar. Andrea, if you are agree, let's wait a few moments before starting our presentation to allow everyone to connect.
Perfect.
In the same time, some words about today's topic that intends to provide a general overview into the world of SIL certified safety relay, always widely using the process automation application. A little explanation on how our meeting will take place today. Our webinar will be mainly divided in two parts, and a first part dedicated to a short presentation where Andrea will introduce the main concept related to safety relay and their application. And the second part will be left free for your question on the topic, in which Andrea and I will try to give an answer. I kindly ask you to use a question and answer function for your question and not the chat of Zoom.
Okay, Massimo, we can go.
Well, Andrea, I think we can start now. Let me give some information on today's speaker. As already mentioned, I have a pleasure to have with me today Andrea Spolar. Andrea is a global account manager at GMI. He has over 20 years of experience in the machine and process automation market. His main area of activity is in the industrial control process, in hazardous area application involving signal conditioning, remote control, and the bus interface. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. Andrea is a functional safety engineer from 2016. And I, Massimo Pagani, product manager and technical support at GM International. I have been employed at GMI for about 9 years. And my main role is to receive and process customer technical requests and assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing offices to promote GM products worldwide. I'm a functional safety engineer from 2020. Well, some words to introduce my company in short. GM International is an Italian company born from the experience of Elcon instruments, and for over 25 years has been designing, engineering, and manufacturing a complete range of SIL certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in various industrial sectors such as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. All our products are tested one by one and must conform to the strictest worldwide specification. And in addition, all our products are entirely designed and produced in our headquarters in Italy. And last but not least, they are covered by 5-year warranty. Next slide shows how GM is located around the world, with over 200 people who make up our staff distributed on all continents. We have products stock distributed in our main branches in Dubai, Singapore, Houston, and Moscow, and in other parts of the world. GMI has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activity is complete pre and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the products. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in an highly automated process. The goal of our company is to supply and guarantee innovative and high-quality products. All our products are tested one by one and must conform to the strictest worldwide specification. And again, our products are tested and certified by over 15 independent UV agencies and laboratories. And they have certification available for different market applications. Europe, America, Korea, China, India, Russia, etc. According to the new ESC 16508, the seal certification of the product is no longer valid if not supported by the systematic capability design certification. For this reason, all our products are designed to adhere to the functional safety management seal-free systematic capability certification. Additionally, over 10% of GM employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and development department. And again, I repeat that all our products are covered by a 5-year warranty. In the following slide, you can see the wide range of products we deal with. Here we can see intrinsically safe barrier, safety relay, isolators, multiplexers, seal-free power supply, termination board dedicated to the most popular PLC DCS system, hard multiplexer, and so on. Furthermore, our company promotes advances courses on functional safety and safety in AX environments conducted by expert trainers. You can find all the information about it in our website. The last slide lists some of our main collaborators and customers distributed among system vendors, APC on them, and end user. Well, we can introduce today's topic, where we will analyze why it's important to use certified relays in a safety application. Let's start by introducing the concept of SIF, Safety Instrumented System. SIF is a set of subsystems that make up the safety loop. And within the safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provides for limiting the current towards the hazardous area or to isolate field instruments. And in turn, the signal sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS, or the PLC DCS system, which will decide on any action to be taken to make a plan to safe. And again, power interfaces, as can be a safety relay, which will then act on a valve and on an actuator, which allow us to bring the system safety in case of need. The main concept that needs to be understood is that every single element of the SIS must be sized with a seal level, such as to allow us to obtain the overall seal of the SIS required. All components of a SIS, including power supplies, to which must be safety related and have a seal level. This helps us to have a safety loop, and with the correct redundancy, a loop with high availability to the process. Well, Andrea, I see that we have the first poll for our
one thing, Massimo, because one attendee in the unit registration make a question about the SIL and they asked if the use of SIL 3 safety relay is enough, or also say the parameter of the SIL device must be, say, introduced into the calculation, and of course if these parameters are necessary in the calculation. And the answer, of course, is yes, because every single element is, let's say, influencing the SIL parameters of the loop. And if you are not sure, if you don't have SIL certification or made a calculation about a single element, you cannot claim to have the loop SIL compliant. So it's very important. Every single element must be included into the loop, yes, into the calculation. Okay. Yes, we have a short poll. We'd like to have your let's say opinion and what do you use, and let's say type of relays. If you use just standard relays or relays with the SIF certification, or relays with the SIF certification and line monitoring. So that is, we see the trend is going to the much more to the third in safety, because nowadays people like to have using system with supervised card, so that can detect any failure on the loop, any failure on the load, and they ask also that the relays must be with the line monitoring. But just have your opinion of course, what you are using in your application. That is important for us. Okay, let me finish that. I hope you already answer. I'm terminating that. Thank you. I see that most of you use it with a line monitor relay. Okay, good. And we can go to the presentation, continue with the presentation, Massimo.
Okay, let's start examining those that are a fundamental part of a SIS. Let's talk about safety relays. The safety relay can stop or initiate a movement in a controlled, safe manner by opening, closing valve, start-stop motor, and so on. They must conform and adhere to the ESC 61500 in the industrial sector. Industrial standard, sorry. And not only oil and gas or process industry, but in general, a safety relay can be used where a failure of a relay can cause serious accident to human, environment, assets, and or image. Well, but what are the typical cases where a safety relay is required? So typically, we must use a safety relay in all those applications where the controller, the digital output card of a PLC, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved, or in those applications where multiple contracts for the simultaneous activation of multiple loads is required, or even in those applications where the safety function that the controller must perform needs to be inverted. Well, Andrea, it's your turn for continue the presentation.
Thank you, Massimo. If you have any questions, just use your Twitter button, send to us your question. Okay. Let's talk about typical application for safety relays. So basically, it's not necessary to use a safety relay if already your system is safe. But there are cases where you need, as Massimo said, you need to extend your power, or you need a special function, need a special line monitor. So in that case, you use or you have to use safety relays. So typical application are, most of them are solenoid valves, and ESD and firing gas are the most common. ESD, I would say, but also firing gas is a lot required. And you can have also beacon or signaling device. In general, you can have it. that are driven through safety relays. You can have a burner management system, BMS, and also AC or DC motors. So the application is very simple. It's a open or close load or start and stop motor. So it's very simple, but it must be safe. In this case, would say that, and that is the topic of this webinar, is that you cannot use for safety loop and standard relay. It is for completely forbidden, because only a safety relay, still certified relays, is a relay with a non-guarantee ability to perform a given safety function. So there is a guarantee that hardware, that relays, is able with very high percentage to perform the safety function. We are talking about a low demand application, so application that must be, say, performed only in special cases, special case of emergency, in case of problems, in case of special conditions. So not high demand. So low demand, it probably is once, less than once a year, but that relay, as we said, has to perform the safety function. And it's on demand. So we have talked about solenoid valve can be open or close a valve or activate a fire extinguisher system. Most of the time it is ESD. So when the safety function is normally energized, so in case of fault, you should de-energize your load. So DTS, de-energization safety, or DTT. The other way around is a fire and gas system where application is normally de-energized and you need to energize in case of safety. ETS, energize to safety. And GMI has, of course, different relays, maybe also the same relays, but there are different applications for, or different hardware for the different applications. So we say that there are, the previous slide, we let's say, we discriminate, we divide the application ETS, energize to safety, to DTS, de-energize to safety. So we can have 4 different conditions. So your coil, the DCS or the PLC system, is normally energized, and the load is normally energized well. So normal opening relay contacts. You can have also the other solution where you have a normally de-energized relay coil, normally de-energized load, and normally open relay contacts. Also, the other 2 can be a mix of the situation, but you can have on the picture on the right side, you can see what is the meaning, and this is, for instance, internal circuit for our relays, where we have 2 situations. We have the first, which is the normal energized load. You see that we have 3 relays that are connected in series, then are normally open in this case, but and the thing is, in this case, when you have a normal energized load, you should open in case of emergency, in case of problem, and there are 3 relays that will open simultaneously that are connected in the series. For normal energized load, it's different because you should close the load in case of emergency. So, and the 3 relays are connecting in parallel. But let's look at the next slide, probably are more simple for your understanding situation. Okay, so here we have the coil, which is normally energized. So your system is normally energized, and the load is normally energized as well, so it's activated. So in case of safe state, you need to open the contact by de-energizing the coil. That is simple to understand. Always for non-energized coil, so your contact from the system is activated, my load is open. So in case of safe state, I should close my contact on the load by opening on the system. So it's completely the other way than let's say the first pictures. Let's look at what happens in case your coil is normally de-energized. I can have a situation where my load is activated. So in case of failure or problem, I should open my load by energizing the coil. And we have the fourth case where we have we compare normally energized, normally de-energized situation, where it's easy to understand that are completely the opposite. So those are the main cases you may find on your application by you're using your system. That can be a PLC or DCS from main producers like Siemens, like Emerson, and so on. But let's look in details. So what is required for functional safety for seal application? So basically, when the load is normally, we're talking about normally energized coil. So your contact is activating our relays, okay? And the application is normally energized. In this case, the load is activated. So we see that just one contact on the system, on the load side, is sufficient for reaching a SIL2 application. If you want to go to the SIL3, we are required 2 relays in series. Okay. So in case of safety, just one relay will open, is a necessity to be open to reach the safe state condition. But I can have also the situation for normally de-energized, okay, application, where I have my contact, my coil, which is not energized from your system, and the contact on the field side, which is open, and the one contact you can see that is sufficient for reaching the SIL1 application. I would need the second relay connected in parallel to assure a SIL2 level. And it's easy to understand that for the SIL3, I would need the third relays. And you see that are connected completely in parallel. So only one will be, let's say, sufficient for activating the load. But there are some cases, easy to understand that for safety, we can have this kind of architecture. It is simple and very good in safety, but has some problem. Okay, we talk about availability, and availability is one important topic for the today applications, because availability means that my system must be available in any case. Okay. It must be, let's say, my system must be powered, and I should continue with my activity without having any problem on the hardware side. And I see that in this application that, if you remember, was SIL3 for non-energized, because I need just 2 relays. I see that it's very safe, but availability is very low, because if one relay will open accidentally, the system will stop. My production will stop without any safety reason, because I don't want to open, and my system, my circuit will open accidentally. So it's very good in safety, but it's very bad or very low in concerning the availability. Also, this architecture, which was SIL3 for normally de-energized, is very good in safety, but the availability is very low, because just one relay can stuck or close accidentally, and my load will be activated without any reasons. So concerning the IEC 61511, availability is not say taking count. So these are just the normatives, just taking count about the safety. So basically, if I would use this kind of relays, I can have I can reach my safety condition, is compliant for my application, but I would, let's say, lose in terms of availability. And it is very, very important in some application, of course. We also have relays that are this kind of architecture that are good for safety, but for availability, you can understand that is has some, let's say, disadvantages. We want to also show you this kind of different architectures that for non-energized load. And just to give you more information, what is availability, what is safety, we have different architectures. So the 1 out of 1, which is the architecture, let me highlight that. Okay, no, sorry. Okay, yeah, 1 out of 1, which is the you have 1 relays for non-energized. 1 out of 2, 2 relays are connected in series. We are talking about normally energized load. Okay, so 2 relays in series. 2 out of 2, and we have 2 relays in parallel, which is not basically good, but just for an example. 2 out of 3, where we have the voting system. So I need at least two relays that are giving the same information for performing my functionality. Here in the table, the right table, I can see that architecture 1 out of 1. I can have the probability of safe failure per year. Okay, safe failure means how available is my system, and probability of dangerous failure per year. How safe is my system? So I would say that with this architect 1 out of 1, the first line, this is the probability of failure, safe failure per year. It would say that I can have a safe failure every 25 years. I can have a dangerous failure every 50 years with this architecture. If we will look at 1 out of 2 architecture, it is a completely different, because I would say that the second line, I increase a lot of my safety because I have, let's say, a multiplication by 50 times of my safety. So my system is completely more safe because I have 2 relays in parallel in the series connected here. Okay, but I reduce my availability because I just 1 relay that will open will stop my plant. So I increase my safety, but I reduce a lot availability. If we look at the 2 out of 2 architectures, we see that we reduce a lot the safety, but we increase availability. But of course, cannot be used, or it's not performing in terms of safety. So it would be good if would perform in safety, maybe not in availability, but safety is a first, as everybody knows. But if is so low, we cannot use for such application. If we look at the 2 out of 3 architecture, we see that this voting is very good for safety, and also would say good for availability. But I would need 3 relays that are voting for the same function, and 2 of that should say and should give the right information, the same information. But at GMI, we have, say, differentiate a little bit. I would show how we differentiate. Now we have another poll. It's a very simple, and I hope you can understand. You can answer. Of course, you understand what we say. What feature for safety is most relevant based on what we said? So safety level, safe-free, high availability, only one suitable for non-energized and non-de-energized application, and multiple contacts. What is a multiple answer? Is you can answer to multiple questions, of course, because probably there are more functionality that you are looking for on the relays. No question from you, so perfect.
No, for now.
Not for now, okay, yeah, but you can make later on. We have, as Massimo said, we have another part where we have a question and answer. So hope we will finish in 1 hour, but not sure. So maybe we go through maybe another 40 minutes would be probably, depending also on your question. Okay, thank you for answering. We can stop right now. Okay, stop it. Perfect. And most of you say that it's important, safety free and also high availability. Okay, good. And we can go on with the presentation. Okay, this is what we did at the GMI. The architecture is completely changed. We don't have only 2 relays in series, 3 relays in series, or 2 in series, 3 in parallel. No, we changed it. We decided to use this kind of architecture where we have 2 in parallel that are connected to the load with other 2 relays in parallel. Why is important? Because by having this kind of architecture, we can improve. Let's make an example for the normally energized application. So the relays are completely closed. I wanna, in case of safety, I should open on demand. So I should open on demand, and I see that the 1 relay fault is not sufficient for a dangerous failure. So if a 1 relay is stuck on its position, is not sufficient because I can open the circuit because you see that the 2 relays on this part are open and the circuit will be open even if this is failing. Okay. For normal de-energized application is a little bit different, but is very good because also when I close my contacts, if 1 relay is not closing, I see that my circuit will be completely closed. So I can perform my function even if I have 1 failure. Both for non-energized and the normally energized. So we can use the same architecture, you can understand, the same architecture for both applications. They are not only parallel, only in series like the previous, but they are connected in different ways. We improve the safety. Okay, we improve the safety. And but what happens for availability? And availability is as from the poll. I've seen that is also very important for a few of you, but I think for a lot of you. In this case, for non-energized, I see that 1 relay fault is not compromising my safety function. Understand this picture because in this drawing, because it's completely different. I'm in a situation where I don't want to open. I'm in this safety situation. My system is running well. I don't need to open because of any emergency, any problem. Just want to run. And I got a problem on 1 relay. So 1 relay is inside 1 inner relays of the 4 that compose my modules, like D5096, for instance, has 4 relays inside. 1 is relay will phase. I see that 1 relay fault is not sufficient to de-energize the load. So my system is running at the same time. This is for normally energized. And what happens in case of a normally de-energized application? I don't want to close my contact, but 1 will close by accident. And my system is not will be not activated. The sounder or the light there won't be activated because these 2 relays will let's say assure that the circuit will remain open. So we have seen that this kind of features, this kind of architecture will improve a lot the safety and also the availability. So 1 relay fault is not sufficient for let's say activated or compromising safety function. this case, we call in the safety is called hardware fault tolerance equal to 1. So I can have one hardware fault tolerance without having problems. There is one question, probably.
Yes, Andrea, we have the first question of today. One of our attendees asked us how to detect one failed relay contact.
Good. Yeah, you can answer, Master, probably.
Yes, typically for all our safety relay, we have a safety manual where inside is described a special procedure called T-proof test that allows us to detect if inside a safety relay we have a contact to fail. This procedure, step by step, drive the customer, the technique to detect
the failure.
A failure.
But
yes.
Yeah, we can also say another point, I guess, Master, about the line monitoring. There are relays with the line monitoring. So first, you should use line monitoring relays if you want to detect this kind of failure. In this case, there are two relays, the D5294S and the D5295S, that can detect the relay fault, the inner relay fault.
Yes,
so not all.
It's able to detect the failure of the internal coil of the relay, the electromechanical relay.
And this will be reported to the system through, there are different ways, through fault contact out, or through mirroring, probably, or Modbus.
Yes. No. It's possible to report the fault in some ways through the mirroring system, or through Modbus, or to typical digital input card of the DCS dedicated to the purpose.
Okay. Good. We can go on. Yes, we already seen that at this point why choosing a relay with the built-in diagnostic, why is important. We say that a smart relay should be used if a diagnostic line monitor is required. Okay, only in this case. So because there is a point, because if you put a relay interposed between the system and the load, such a normal safety relays, this is act as a wall. So also, if you have a built-in line monitoring capability on your controller, on your system, that line monitor will be stopped will die at the relay coil completely. So you are not able to detect the load. You will be able to detect the line control between the system and the relays, but after the relay call, you can't have this information. So if you're using control with the line monitoring functionality, and the relays, standard relays, will stop your diagnostic capability, will limit your diagnostic capability. So indeed, the PLC DCI diagnostic can reach only the coil side of relay. And the field side will be completely unknown. So you don't know if you are having any problems there. And also the safety relay, because act as a wall, because blocks the line monitoring pulses. So if you have a line pulse testing from your system, that will be blocked by the safety relays. In this case, a smart relay or relay with the built-in diagnostic will be necessary to extend this kind of functionality. So standard relay cannot, standard safety relay cannot, but the smart relay can, of course, in this case. So we have some conclusion about this first part, which is the improve the safety diagnostic limit. So safety relay shall maintain the safety loop requirement, C2, C3, along the system diagnostic to present. So you have, if you need to maintain a certain cell safety on your loop, you should use this kind of safety relays. High availability and fault tolerance. So this prevents from spurious trip, increase the availability beside the safety, and are very important on the process control. SIF certification for the product must be supported by the design certificate systematic capability. It's very important also this point because the SIF certification alone for the product with the new normative is not anymore valid because it must be supported by the systematic capability design certification. So also the design for the product is very, very important. We see that there is a cost reduction, so all-in-one solution, same module can be used for ESD or fire and gas application, and the same metrics relay, for instance. And there is a complete pass testing compatibility. So when you are using a safety relay, the important thing that that relay has to be compatible with the pass testing from the system, because in some cases this pass testing cannot be excluded, cannot be removed. It is working, and if you are not using a safety relay that is compatible with the pass testing, maybe you can have some flickering on your system. Okay.
Andrea, we have another question.
Yeah.
Is line monitoring extended till field device or only till relay coil? Well, we can say that we have two different type of safety relay. The first type is the typical safety relay where the digital output capability is only the coil of the safety relay, but we have another kind of safety relay called smart relay that we have the diagnostic inside that allow us to extend the diagnostic capability from the digital output card of the PLC till the field devices.
Yes. So the thing is, smart relay can extend the diagnostic till the
capability. Yes.
Okay. To the flow. Okay. Thank you. So I think we probably closing this presentation. Now is a question for time for question and answer. Let me switch to the new presentation. In the meantime, if you have any question, don't hesitate.
Well, in the second part of our meeting, we show which are the typical requests that the most frequently are asked to us on the relay topic. But we have another question, Andrea.
Yes.
What are the availability figures if we use 4 relays as shown in the one of the slides?
Which one?
I don't know. I think in the
what are
previous
availability
presentation.
figures if you use 4 relays that is shown in one of the slides? Availability is hardware fault tolerance equal to 1. So we can have one failure on one relay side, and that will be safe as well. So hardware fault tolerance is equal to 1. Hope this is the question, the answer to your question. Okay, so we can go to the new one with the question and answer. Okay, there is some question that you made during your registration time, so we try to collect it here. So safety relay installation in hazardous areas.
But we can say, yes, it's possible to install a device such as a safety relay in the hazardous area, placing it in a special enclosure certified for the installation area, or as shown in the slide, in more cases, there are safety relay certified for installation in hazardous area, especially suitable and certified for installation in Zone 2, Division 2. This allows us to install the relay as close as possible to the load, with great advantages in save cable. This means save cost. Well, Andrea, another question?
Okay, yes, go to the next one. So fast testing compatibility, what is it? So there are some more explanation that people need it about that.
Okay, and we can say that almost all PLC DCS systems have the possibility through a series of pulses to test the status of the line that connects them to the relay coil. Compatibility with these pulse trains is very important in a safety relay. First of all, to allow the correct test of the line, and moreover to avoid that these pulses cause the chattering effect in the relay contact, or to avoid spurious activation or deactivation of the loads, as well as the damages of the relay itself. This functionality is fundamental, especially in fire and gas application, where it's important to know that the health or status of the line, as at the time of the request for intervention, we must be sure that everything will work correctly.
Okay. Sorry, we missed something?
Yes, we lost the presentation there.
Oh, well, sorry for that. Okay, good. And another question, is there any solution offering multiple contact output?
Yes, there are solutions that provide for multiple output contacts controlled by a single input. These multiple outputs allow us to have multiple loads connected and driven simultaneously. An example for this is the D5290S-078 GMI relay. These allow us to drive at least 2 C loads with only one relay. In fact, this type of relay allows us to have application in which we can simultaneously drive 2 normally energized SIL3 loads, or 4 SIL2 loads, always normally energized, or even 2 normally de-energized SIL3 loads. Of course, the possibility of having different loads driven by a single relay allows us a considerable saving in terms of space, as in only 22 millimeters, we have the ability to control different applications.
Okay, good, Massimo. Thank you. So we have another question, which is one unipolar and or two bipolar wires loads. So that is another typical application you are having a lot of times through the customers, also when you are assisting locally.
Typical question. The SIF relay can be connected in unipolar or bipolar configuration. A bipolar connection allows us to completely isolate the load, and this is recommended especially in application where the load must be powered with high voltages. From an electrical point of view, this type of connection gives us greater safety thanks to the complete isolation of the load. In unipolar connection, isolates the load only on one of the power supply lines and allow us to bring a negative to earth in case of need. Furthermore, this type of connection allows us a great benefit from the point of view of cable savings.
Okay, so difference between bipolar and unipolar connection.
Yes, two typical connection for the safety relay.
Okay, good. How choose a relay? That is very, say,
okay, well, the choice.
Common question, yeah.
Yes, the choice of the correct safety relay must be made taking into consideration various factors, such as compatibility with the PLC pulse test system, the type of coil power supply, the safety function that it must perform. In this regard, it's important to say that the choice of the relay is fundamental relative to the type of load and the safety function it must perform. In fact, it would be very harmful to choose a safety a relay that performs a safety function different from the one required by the application we have to create. Suppose to choose a relay suitable for normally energized load to drive a fire and gas system. This will greatly increase the risk for our system, as using a wrong relay in its safety function increases the chance of failure in case of a relay intervention request. Therefore, it's important to choose the relay correctly based on the safety function it will have to perform. And furthermore, let us not forget that the choice must also be made bearing in mind the need for a diagnostic capability on the part of our relay, the need for single contacts or multiple contacts, and finally the contact rate of the relay. Even in the later case, the choice is important, as choosing an incorrect contact rating can have serious consequences for the state of health of the relay and therefore of the entire application.
Well, Massimo, so no question, no new question from customers, from attendees. Okay, can the next one, can the fault for monitoring relay be mirrored directly to the PLCDO? That is a very, very, say, important point, because it's often required by for, say, engineering reasons, for cost reasons. Massimo, maybe you can explain you.
Yes, this is a typical question that involves the use of the smart relay. There are relays that when they detect a fault in the field can, through a variation of the dynamic impedance of its input, send a false signal to the most modern supervised PLC DCS system. This function allows us to reflect information relating to the field fault directly to the supervised digital output card of a PLC. This is in both in the off state through the pulse test system, and in the on state by reading the static return of current. The digital output card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allow the supervised digital output card to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose.
Is of course not available for all systems, so not all systems can read it, but it's we experience with a lot. But maybe if you have any question about which system are compatible, and we can give you the details, of course. Okay, good, Massimo. So next question is, can the fault for a monitoring relay be interfaced with a field bus?
Yes, there are particular safety relay models called smart relay, which can provide complete diagnostic information through Modbus, multi-drop RS485 protocol. If a Modbus master is available on the system side, up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when requested, makes available its value for reading or writing. But what are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the smart relay present on the same bus. Multi-drop connection is possible, and the communication can cover a distance of up to 1,200 meters. Another advantage is the possibility of not using a dedicated digital input card system to monitor alarms. And again, this allows us to have significant saving in terms of cost, and also real-time information on the type of alarms and on the health of the load and the line. And again, it's possible to Modbus a complete remote programming of the relay.
So we see here how the fault is working. So it's triggering the fault contact. The fault contact is triggering the Modbus, and the Modbus will say the system will act as a Modbus master and asking what is happening. The important things, Massimo, maybe we can also say that over modulars we can detect the specific failure information. So you can discriminate if it's a fault on the power supply, fault on for short, for open circuit, whatever. And it is completely different, because if you're using a fault contact, if you use a mirroring, you just know that there is a fault. You don't know which kind of fault.
The Modbus is more specific in respect to the other system.
Exactly. Okay, well.
Another typical question regarding a SIL-free relay can be used in a SIL-2 application.
Okay, this is my turn for questions.
Yeah.
And you know, you're aware about the SIL that can be 1, 2, 3, and 4, which is the most dependable. We would say that, of course, SIL-3 relay can be used in SIL-2 application, but not the other way around. So we cannot extend, because SIL-3 is more safe than SIL-2. And the important things you have to keep in mind is that if you're using, in this case, a seal level module with the hardware, say specific hardware, with the seal rating, which is higher than the ones we are looking for. So in this case, you need a seal 2, but you're using seal 3 modules. In this case, you can reduce the frequency of T-proof. So T-proof testing is necessary because you have to say retest every certain year, which is declared by the manufacturer, the hardware you're using. And in this case, we can see that, for instance, if you're using C3 hardware, it is certified for 1 year, and after 1 year, you should test it to return to the seal 3 level. This, from the beginning, can start for 10 years. So you can have a seal 2 that is valid for 10 years, and that is declared by the manufacturer. We have also another example here. So where you have the, where you have the this kind of drawing, you should, is just for your understanding. So you start from today with the hardware, and you are in a sealed 3 situation. After certain period, you should you see that you can, if you want to maintain the certain seal level, you go to the seal 2 band, and after another period, you arrive at the limit of seal 2 to the seal 1. So in that case, you should make a test. This graphic show how will change your seal rating for the hardware you're using based on the testing. So after the period, in this case 1 year is just an example, you test again the hardware, and you start basically from 0, so from the same situation as it was new. And this is the blue line is showing how the seal level for your hardware is changing by the time, by the use. And so the probability for demand, which is the influence, the seal rate of your hardware, degrades by the time, so will be reduced by the time. Okay, so let me go to the next.
Thank you, Andrea. Can you give us some words about design aspect on the safety relay?
Yes, there are different situations. Of course, the seal level can be achieved by using architecture. So architecture, as we have seen, for instance, for the matrix relays that we are using. But the same architecture can be used inside, also for the components. So the components inside, such as resistance, condensator, inductance, whatever, also can be used in different architecture to improve the safety for your hardware. Also, the important thing is the beta factor that must be considered. So the beta factor is a factor that, if you're not aware, is the probability of failure of the same components at the same time. So if you're using the same components in the hardware, in something, also the same module, same PLC, same field instruments, the probability of failure of those say modules that maybe are produced at the same time in the same batch is more or less the same. Could be those hardware could fail probably at the same time, or maybe with a very small difference. And the beta factor reduces the safety of your system. So in design, of course, we are using special components for safety relays, special components that give safe failure fraction, which is higher than standard and declared especially. And so it means better components and better results. We are using components that every single component is declared. There is declared failure information There are no standard components. That is also very important. We are using gold plating contacts, sealed relays, and single multiple internal contacts. So there are a lot of aspects that make safe a relay. Is not standard, and every single component for every single component there is some information regarding the failure rate, dangerous failure rate, and the safe failure rates. In the I just introduced this slide, and the FMEDA is very important for every single component. The safe failure, dangerous failure are taken in count into the FMEDA calculation for the hardware we are proposing, we are using in the safety loop. And we are talking about MTBF for dangerous failure must be really evaluated for safe and dangerous. But of course, the safe will bring just me to a safe situation where I will stop, I will lose my availability. But if I have a dangerous situation, so some failure that will lead to a dangerous situation, that in that case, it's very, very dangerous. Okay, so next question.
Another question typically is why gold plate contacts are important in safety relay.
Okay, so we're talking about the gold plated contacts. Basically, a relay you use when you need to extend your rating of your relays. So basically, DO card stop at 500 milliamps. So then cannot go over. Then you are using a relay in the safety relay, which can grant 5 amps, 10 amps. But there are a lot of situations where you have a little currents, and then those little currents can cause oxidation and can lead to spurious trips, nuisance trips. And that's why it's very important to have relays, safety relays with the gold-plated contacts. Okay, so the gold-plated, the gold into the contact grant higher reliability also for little current. So you don't have any problem regarding the oxidations.
Yes, thank you. And again, coil voltages and relay load currents. Some words about it.
This, okay, here is just a slide that shows what possibility you have. You can have 24 volt, 48 volt, and so on, coil. Can be for normal open contacts, normal closed contact, multiple, both for normal open, normal closed, and the relay contact can be 3, 5, 10 amps. So those are the different situations you may have on your application.
Okay, another question that involves the smart relay is SIF-free relay with SIF2 diagnostic. How is it possible?
Okay, well, this is another interesting point because we are talking especially smart relays. The diagnostic is, of course, is something which leads to the software situation, software development, software controlling, and is anyhow is certified for SIL2. You see the yellow circuitry, but the coil, so the safety function is a red. They can coexist in the same hardware because the diagnostic is certified for non-interfering with the safety function, which remains SIL-free. So we have SIL-3 relays with the SIL2 diagnostic, which is valid for using the safety application.
Okay, the last typical question, differences between process and machine safety relays.
Okay, this is the last one. So we are having inquiries for different safety relays, and we are talking that for process application where we are working, we are talking about valve control, ons, light, sounder, bit. There is no manual control. Manual control is not permitted. So there is the system which is drive the relay. Relay is closing or opening instantaneously. No delay, no manual control. While for machine application, there is a different, it's also SIL, but there is a certificate which is PL, protection level, and they use for safety gates, light grids, speed, standstill, different situation, complete different application. So you see the red button. The red button is applied, is driving, and relay used for machine application certified PL. Okay. In this case, there is a manual control, also knowledge. So in this case, you will stop until somebody will say, we go there, will restore a situation, and will reset relay. Then you can start again. So there is a complete manual control. There is an input for manual control, and which is not allowed in the process application. So there are different relays for different application, process and machine. We are in the process. Okay, I think we came to the end. We remind you that this is a free webinar from GMI. We have other free webinars, but they are available on our website. You can go through our dedicated page and register yourself for another topic. We have we talk about also about application for safety isolators, and we talk also about functional safety, EX application. Cybersecurity is a new topic, so you can go to this page and see what will be available for the next month. And we are now for programming for July, August, September. So now I think you can only see it till the end of June, but will be updated soon with the new topic. Also, we have all the webinars are registered in our website, so you can go through our special YouTube channel and look for this webinar, and also for the others. If you want to review or share with your colleague, you can, of course. Let me just ask you to answer if we did good or not. Don't be, let's say, do what you say, do what you want. It's completely anonymous, but it's just be used for, of course, for improve our presentation for the next one, and maybe change something. Thank you for answering. We have probably the last question. Okay, thank you to all of you. Thank you very much. And perfect. Thank you for, I will stop right now. Thank you again. And let me go to the last slide where we have also our name, emails, and face, so you can remember us. If you want to write us, if you have any further question, don't hesitate. We have a lot of application cases in our records, so we can also share with you if you need it. Okay.
Okay. Thank you, Andrea. Thank you,
Massimo,
for sharing your knowledge on today's topic with us, and thank you to all our attendees, and see you from the next GMI webinar.
For sure. Wait for you. Bye-bye. Thank you.
Bye-bye. Thank you.